Learning mathematics is very, very difficult to many people, second only to learning how to speak English. Do you have difficulty? Don't be embarrassed. It's a lot of people don't know what they're doing when they get up there and do their mathematics. We're going to introduce you today to Fort Bend Tutoring, honey. Personalized math tutoring is the solution.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today's lesson is going to be about dividing polynomials. All right, let's check it out. In problem number 1, we have negative 28x to the 14th power divided by 4x to the 3rd power. Anytime you're dividing by one term, all you have to do is reduce the coefficients here, and if you have any like bases, subtract your exponents. So that's exactly what I'm going to do here. So I'll be simplifying this by saying that 4 goes into itself once, and that 4 goes into 28 7 times, just like that. As far as your variable is concerned, ladies and gentlemen, it's going to remain wherever the largest exponent is. So as long as you have positive exponents, your base, that variable x, is going to stay wherever the largest exponent is. And in this case, it's on top. So I'm going to be bringing down a negative 7. I have my variable x, and then subtracting the exponents, 14 minus 3, I'll end up with x to the 11th power. So that's my answer. That's it. I end up with negative 7 x to the 11th power. Yeah, that's right. The problem's done. Let's move on to the next problem. Okay. In problem number 2, you have 2x to the 4th power y to the 6th power minus 3x cubed y to the 4th power plus 5x squared y cubed all over x squared y squared. Anytime you're dividing by a monomial, one term in the denominator, what you can do is you can expand this problem. I can rewrite this as 2x to the 4th power y to the 6th power over my denominator of x squared y squared minus 3x cubed y to the 4th power over that same denominator of x squared y squared plus 5x squared y cubed all over that same denominator of x squared y squared. So what I just did here was expand the problem by writing each term in the numerator over that common denominator of x squared y squared. Remember, you can only do this when you're dividing by one term, a monomial, in the denominator. Okay? So from here, I simplify each one of these fractions. All right. So I'm going to end up with 2. My largest exponent on x is in the numerator, so I'll end up with x to the 2nd power after subtracting 4 minus 2. My y is going to be to the 4th power because 6 minus 2 leaves me with y to the 4th power. All right, I'll bring that up so you can see. Then I'll bring down that negative sign. I'll have 3x to the 1st power because 3 minus 2 leaves me with x to the 1st power. And then since my variable y has its largest exponent in the numerator, it will remain in the numerator, and all I have to do is subtract the exponents. So 4 minus 2 leaves me with y squared. Next, I'll have a positive 5, and notice how I have x squared over x squared. Well, that means that these will just cancel out because anything over itself is 1. So my x squareds will cancel out here, and when it comes to my variable y, notice that my largest exponent is in the numerator, so I'll end up with y to the 1st power after subtracting 3 minus 2 on that base of y. So that's my answer. I have 2x squared y to the 4th power minus 3xy squared plus 5y, and that's it. Putting a box around my answer, ladies and gentlemen. That's right. And that's the answer. That's problem number 2. All right, let's keep it moving here. Problem number 3. In problem number 3, I'm no longer dividing by a monomial. I have a binomial. And though there are several strategies in solving a problem like this, such as synthetic division, I'm going to show you in this video how to solve the problem using long division. So I have my polynomial in the numerator here. I have 4 terms in the numerator divided by 2 terms in the denominator, and I'm going to use long division. All right, let's check it out. So first of all, the 2x minus 3, that's going to be my divisor. So I have 2x minus 3, and all of this is going to be going into my numerator, which is going to be 2x cubed minus 9x squared plus 11x minus 3. So when setting up your long division problem, make sure that all of your terms are in descending order, starting from your highest exponent all the way down to the lowest one. So here I have x to the 1st power. This negative 3 counts as x to the 0 power. And then my dividend here is going to be set up as x cubed, x squared, x to the first power, and then x to the 0 power. You want to have your terms in descending order of your variable, and it is. Then you're going to focus on the first term in that divisor there, your binomial. I want to know what I need to multiply 2x by in order to get 2x cubed. That's what I want to do. In order for 2x to become 2x cubed, I need to multiply by x squared. All right, and then whatever I had to multiply 2x in order to get 2x cubed, you need to distribute that to both terms, not only to the 2x, but also to the negative 3. So in multiplying this out, I'll have x squared times 2x, that gives me 2x cubed. X squared times negative 3 gives you negative 3x squared. And part of the process of solving this, ladies and gentlemen, is to change the sign after you distribute. So after you distribute, make sure you change the signs before you continue on. So that means that this 2x cubed will become a negative and this will become a positive. Remember, that's part of the process. From there, I'm going to cancel out these 2x cubes. A negative 9x squared and a positive 3x squared brings me a negative 6x squared, and then I'll bring down a positive 11x, just like that. Okay, so I'm back to referring to this first term in the binomial. What can I multiply 2x by in order to get negative 6x squared? Well, you're right. I'll need negative 3x in order to make that happen. So now that we figured out we need a negative 3x, you want to distribute that to both terms. So negative 3x times 2x gives us a negative 6x squared. Negative 3x times negative 3 is a positive 9x. Now remember, after you distribute, you have to change the signs. You'll hear me saying that a lot. Change the signs. So this becomes a positive 6x squared, and this is a negative 9x. All right, so we'll be combining our like terms now. The 6x squareds will cancel out, and 11x minus 9x is going to be 2x, and then you'll bring down this negative 3, just like so. What do we need to multiply 2x by in order to get 2x? Exactly, we need to multiply by 1, so I have 1 here, and you'll distribute the 1. So 1 times 2x is 2x. 1 times negative 3 gives me negative 3. And then, what do we do next? Exactly, we change the signs. So this becomes a negative 2x, a positive 3. Everything cancels out. It terminates with 0. So your answer here is x squared minus 3x plus 1, and that's the answer. All right, let's check out the next problem. In problem number 4, we have x cubed minus 1 divided by x minus 1. So setting this up in long division, I'll have x minus 1 going into x cubed plus 0x squared plus 0x minus 1. So what just happened, ladies and gentlemen? I know originally I had x cubed minus 1, but underneath the division symbol, I'm showing my missing terms. Notice that in the original problem, I didn't have an x squared term, nor did I have an x to the first power term. So what I'm using in this problem are placeholders so that I can organize my terms as I distribute. So the placeholders that I have are 0x squared and 0x for those two missing terms that I did not have in my original problem. You'll see how that will be beneficial very shortly. All right, check it out. I'm starting out with my first term again, that x. What do I need to multiply x by in order to get x cubed? Exactly, I need 2 more x's, so I need x squared. Then you'll distribute. So x squared times x is going to be x cubed, and x squared times negative 1 gives me a negative x squared. All right, and then what do I need to do? Exactly, I need to change the signs. So this becomes a negative x cubed, this becomes a positive x squared, and the x cubes will cancel out. Then 0x squared plus x squared is just x squared, and then I'll bring down that placeholder of 0x. Notice that because I had my placeholder, I was able to line up these like terms of x squared here. If I didn't have that there, it's going to screw up everything, okay? So it's good to use those placeholders for organizational purposes to organize the information. Yeah. All right, so next step. What do we need to multiply x by in order to get x squared? Exactly. I need to multiply by x. And that's exactly what I'm going to do. So x times x is going to give me x squared, and then x times negative 1 is negative x. Notice how all that is lining up again, nice and pretty like, right? Then I need to do what? You're right, I need to change the signs. So this becomes a negative x squared, this becomes a positive x. Don't forget that step. My x squares will cancel out, and I bring down just 1x. Why? Because this was 0x right here, and that's 1x. So 0 plus 1 is 1x. Next, I'll be bringing down this negative 1. All right. So how many times do I need to multiply x in order to get x? Exactly. One time, ladies and gentlemen. One time. So distribute, you have 1 times x is x. You have 1 times -1 is -1. And then what do I need to do? What's that? Exactly. I need to change the signs. Change the signs, ladies and gentlemen. And this terminates. Exactly. So that's the answer. It's x squared plus x plus 1. And that does it for problem number 4, ladies and gentlemen. All right. Checking out problem number 5. For problem number 5, we have the following. We have 12x to the 4th power minus 6x cubed plus 8x plus 12 divided by 2x squared plus 3. Well, let's solve this problem, right? Here, what I'll do is I'll set up my divisor of 2x squared plus 0x plus 3. So I'm using 0x as a placeholder for my missing term of x to the 1st power in my divisor. Now, for the dividend, I'll have 12x to the 4th power minus 6x cubed plus 0x squared plus 8x plus 12. All right, so that's what I have there. Notice, once again, I didn't have an x squared term in the dividend either, so that's why I added a placeholder there. So now we're going to start our process. Remember, we always start with our first term in the divisor, that 2x squared. What do I need to multiply 2x squared by in order to get 12x to the 4th power? Yeah, I need to multiply by 6x squared, and then I'll distribute. So 6x squared times 2x squared will give me 12x to the 4th power. Then 6x squared times 0x is going to give me a positive 0x cubed. It could be positive or negative. It doesn't matter because it's 0, but I'm definitely showing that I have 0x cubed after multiplying that out. Then multiplying 6x squared times 3, that gives me a positive 18x squared. And because of my placeholder, notice how I was able to line that up. Now, what happens next? You got it. I need to change the signs. All right, so the 12x to the 4th power, that cancels out. I'll be bringing down a negative 6x cubed because that 0 is non-negative and non-positive, so it doesn't matter. And that 0x squared won't affect the fact that we're bringing down the negative 18x squared. So I'll be bringing down my next term, which is a positive 8x. And the next thing I want to do is see what I need to multiply 2x squared by in order to get a negative 6x cubed. And that's going to be negative 3x, just like that. So negative 3x times 2x squared, that gives me my negative 6x cubed that I needed. Negative 3x times 0x is just 0x squared. Then negative 3x times 3, that gives me negative 9x. And then what do I need to do, ladies and gentlemen? You got it. I need to change the signs. So this becomes a positive, that becomes a positive, and if you want to, you can just make that a negative. It won't make a difference. All right? So what happens with the 6x cubes? They cancel. I'll then bring down my negative 18x squared, and this will add to give me 17x. And what's happening over here with that positive 12? I'm bringing it down, okay? So I brought down that positive 12, that last term in the dividend. Next, we need to find out what we need to multiply 2x squared by in order to get this negative 18x squared. And we need to multiply by negative 9, ladies and gentlemen, by negative 9. So negative 9 times 2x squared will give me a negative 18x squared. Multiplying negative 9 times 0x is negative 0x. And then multiplying negative 9 times 3 will give me a negative 27. Your next step is to change the signs. So we'll make this a positive 18x squared, and this becomes a positive 27 here as well. The 18x squares will cancel out. I'll be bringing down 17x plus 39. Okay. So our result here, our remainder, is going to be that 17x plus 39 because we can't multiply 2x squared by anything in order to get that 17x. So next what you'll do is you'll have a positive 17x plus 39 over your divisor of 2x squared plus 3. All right, and that's the way you write your result. So anytime you have a remainder when you're using long division, you'll place that remainder over your divisor, and in this case it was 2x² plus 3 for your final answer. And that's it. That's what you do. Okay, ladies and gentlemen, that means that our answer here is as follows. 6x² minus 3x minus 9 plus 17x plus 39 over 2x² plus 3, and that's going to be your result for problem number 5, ladies and gentlemen. And that does it for our lesson today on dividing polynomials. So this is Mr. Witt with Fort Bend Tutoring. As always, please rate, comment, and subscribe. And if you're able, please donate. We really appreciate it. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? Leave a nice comment. Don't just leave something ignorant on there. If you didn't understand the lesson, ask the professor to explain it for you. Don't just get mad and write something ignorant on there.